Okay, today we're going to understand and apply the properties of a rectangle to algebra. So please make sure that you take out a sheet of loose leaf paper if you chose not to print out the notes that go with this. So the first thing that we have to remember is that a rectangle is a parallelogram. If you remember the quadrilateral family tree we talked about earlier in the year, a rectangle has all the properties of a parallelogram and then some more. So if we review the properties of a parallelogram, your opposite sides are parallel, which means these are parallel to each other. Your opposite sides are congruent, which means this is equal to this side is equal to this side. Your opposite angles are congruent, which means this angle is congruent to this angle, and this angle here is congruent to this angle here. Your consecutive angles are supplementary. Remember, consecutive means next to. Your diagonals bisect each other. So if you drew diagonals in here, they cut each other in half if it was a neater picture. And your diagonals create two congruent triangles. Those are your properties of a parallelogram, but also the properties of a rectangle. What makes a rectangle different is that all angles are right angles. So I can draw little boxes in here to show me that I have right angles, and we can say angle A, angle B, angle C, and angle D are right angles. The other property that makes a rectangle unique from a parallelogram is that the diagonals are congruent. So if I measured from D to B, and I measured from A to C, they would have the same length. So AC is congruent to DB. So some examples with some algebra. Again, the first thing we have is a rectangle ABCD. So let's draw ourselves a rectangle. Doesn't have to be perfect. When you're labeling, make sure you go in a circle. Does not matter if it's clockwise or counterclockwise. It says diagonal AC is 4x plus 6. And it says diagonal BD, so this diagonal here, is 5x minus 2. The question says solve for x. If I look at what's given to me, I have the two diagonals. In a rectangle, my diagonals are equal. So I'm going to set those equal to each other. We're going to move the x's to one side. Sorry, that should be a minus. We're then going to move the numbers to the other side, and we get x equals 8. Go back and read. It says solve for x, and that's what we did. For number 2, it says in rectangle, MNOP. We're going to draw MNOP. MNOP. It tells us that MN is 4, and NO is 3. It says find the length of the diagonal. So I'm going to draw my diagonal in. Now what I'm going to do is focus on what I'm looking for and what I have. If I focus on this right here, and I know I have a rectangle, this is a right angle. So if we think back to what we know about right triangles, because I, again, have a right triangle here because of the diagonal, we remember, hopefully, the Pythagorean theorem. So in order to find the diagonal, which is opposite right angle or the hypotenuse, we're going to call that x. A and B, it does not matter whether you call, which one you call 4 and which one you call 3. So 4 squared is 16, 3 squared is 9. If I add them together, 16 plus 9 is 25. Hopefully we remember to get rid of a squared, where the opposite of squaring something is square rooting it. So I get x equals 5. Go back and read. It says find the length of the diagonal. The diagonal is x, so the diagonal is 5. If we look at number 3, it gives us a picture, and it says in rectangle ABCD, the diagonals intersect at E. It says the measure of angle CAB. You might want to trace it from C to A to B. So this blue angle here is 35. It says the measure of find the measures of CAD. So CAD, I'm going to call that one X. And ACB. So A to C to B. I'm going to call that one Y. So if I wanted to find the red angle, which is angle X, since I am told that I have a rectangle, I know that this has to be a 90-degree angle. So I can say X plus 35 equals 90. If I subtract 35 from each side, I get X equals 55. So CAD is 55. If I want to find angle Y here, there's a couple of different ways you can do it. If I look at this, I know that my opposite sides here are parallel. I know that this here acts like a transversal, and this angle here is going to be the same as this angle here, because if I turn or rotate my paper 90 degrees, these are alternate interior angles. And we remember from parallel lines, alternate interior angles are congruent. So angle Y, or ACB, has to be the same as angle CAD. Another option, if you focused on this black side here being parallel to this black side here, and we focus on that same transversal, the 35 is alternate to this one, so that's 35, and 35 plus Y also has to equal 90. Either way is fine to do. If we look at number 4, it says in the diagram below, the measure of angle AEB, let's trace, from A to E to B is 3x. And the measure of angle DEC, so trace from D to E to C, so that's my blue angle there, is x plus 80. It says solve for x. If I look at that picture, my 3x and my x plus 80 are vertical angles. So maybe vocabulary, vertical angles, because the diagonals are two lines that cross each other. And I know that vertical angles are congruent. So I'm going to set them equal to each other. We're going to subtract x. I get 80 equals 2x. If I divide both sides by 2, I get x is 40. Go back and read. It says to solve for x. I have x. Sometimes it might say find the measure of the angle. If I wanted to find this AEB, the red angle, 3 times 40, that would be 120. And the other twist that they could put on it is they could say to find this angle, which is DEA, and hopefully you realize this here is a straight line. So if I do 180 minus 120, that tells me that the missing angle here would be 60, as with that one, because the left and the right angles are also vertical. Please make sure that you write down any questions and either email me or ask me next time you see me in class.